everybody. I hope you're here for Astronomy on Tap and not something else. This is Astronomy on Tap. Okay. This is Christine, and Lizette's first time officially hosting, so we're a little bit terrified right now, and please forgive us if we screw up. We're doing our very best. Okay.
Yeah, so...
Huh? Oh, yeah. Why is this happening? Okay. It's really setting a good space mood, I think, personally.
So as Christine mentioned, she's Christine. I'm Lizette. We also have a few other people helping today. Sam. We also have Adam and Brian here with audio. And Alberto, sorry. And then we also have two UTSA grad students helping us with the merch table. That's Michael Velez, if you want to raise your hand up. And Sam Hart. Somewhere. And then, of course, we normally have Tracy Becker and Vincent Hugh, but today, instead of being our hosts, they're actually our speakers.
Okay. Am I doing this? I'm doing this. Okay. What is Astronomy on Tap? It's this, but also it is an event all over the world at different breweries, bars, etc., where people give free talks about space just to try and get you guys interested in what we do at our computers all day. It is all over the world. More locations are popping up every day, which is very exciting. So if you're ever, traveling, look out for an Astronomy on Tap where you are.
So put simply, you guys come to a bar, have a drink, and maybe learn something about space.
What do we say about this?
Yeah, so this is also just summarizing Astronomy on Tap. So as you can see in the top left, we have lots of fun. Usually we have trivia, so that's what this picture is showing here. Tonight we're actually not going to have trivia, but if you come back next month, we will have trivia and you'll have a chance to win some cool prizes. We also have some really cool speakers. You guys have a chance to interact with some world-class scientists, and we always try to keep it interesting.
Okay, so tonight's AoT. First, we are going to have our exotic, who you've never heard before, guest speaker.
let other people talk about their favorite science topics, I actually get to talk a little bit about one of my favorite science topics, which of course is asteroids. So we're going to do 2 games tonight. One, my word is going to be impact. So those of you guys who've never been here before, when I say the word impact, we go and take a sip. The second little thing I want you guys to do is when this slide comes up on the screen, I want all of you together to say, what is she talking about? That'll bring me in from my tangents of going on and on and on about whatever topic I've gone on a tangent about, and then just kind of bring it all back together. And I'm going to be talking about these 3 main points, which are A, what are asteroids? B, what is the impact that they've had on the Earth in our past? And what is the potential impact on our future? All right. So I promise I won't get you all. Remember, Astronomy on Top is not liable for anybody, so please, if you're driving, pretend to take a sip. Okay, so let's time this before I was threatened already with possibly a physical attack if I go way over. So to start with, what are asteroids? So the solar system, when it formed, billions of years ago, we had a thing of gas and dust that basically started spinning, collapsing, created our star, and created everything else, the planets, the asteroids, the rings, the moons. That's a whole other talk for a whole other time. But the asteroids are sort of an important piece that kind of comes out of this. So how many of you have ever built something from IKEA before? Yeah? So at the end of building your table or your chair, there's always a lot of pieces left over that you think they should have gone in somewhere, but they're sort of just left over and everything else seems to work? Yeah? So that's pretty much what the asteroids are. They're kind of the leftover pieces. So a lot of them formed, just sort of didn't get coalesced into a bigger planet. Some of them might have formed and almost became a planet, but got destroyed and sort of became these remnant pieces. But the asteroids are everywhere. The most of them are at the main asteroid belt, which is that region between Mars and Jupiter's orbits. So you can see the red is Mars's orbit and the yellow is Jupiter. But they're not confined there. There are what we call near-Earth asteroids, which are asteroids that come in a bit closer to the Earth. These are going to matter significantly for this talk because I'm going to talk about the ones that impact the Earth. Very good. You guys are good. Well done. But just before we get into that, the asteroids kind of come in all kinds of sizes and flavors and shapes and compositions. So we do get things made out of, they're all different shapes. You can see a bunch of different shapes here, and that's certainly not all of them. But we also get a lot of different materials. So there's one mission going to an asteroid called Psyche in the near future. This thing is maybe a giant chunk of metal in space. Some of these objects are differentiated. So they sort of did what the Earth did. It got really hot and molten. The metal kind of sunk to the bottom and created a core. And then you had a mantle and a crust, just like Earth. So Vesta, we believe, is something like that. But then we have these things that are just ancient and primitive. So when we study a lot of these asteroids, we're learning about basically the most pristine and ancient material in our solar system. So we actually get to know a lot more about how the solar system formed by studying asteroids. We know about the most basic parts of the solar system. And how do we know about them? Well, we can study them in a lot of ways, but one way is by finding meteorites. Meteorites are the pieces that are left over when one of these asteroids impacts the Earth. And so what we do, and I think I saw my beer come over. I'm going to have you guys hand me that in a second. Thank you very much. So the meteorites are the leftover pieces. So when you all see, we get dust and gas we get dust and meteors coming through our atmosphere all the time. When you see a shooting star at night, you go out, not in San Antonio, but a little bit further out into the countryside. Anytime you see a shooting star, that's a piece of dust or a small rock coming in through our atmosphere and burning up. That's what happens to most things. However, if you have something big enough, or maybe something with the right composition, like something metallic, it'll get through and it will impact the Earth. All right. So, thank you very much. What am I talking about? Well, now I'm going to talk about how they actually have impacted the Earth. So, this you guys might remember from just 2013 over Russia in the area called Chelyabinsk. There was an impactor. It was huge. It was, impactor. You can do it with that one. It was a near-Earth asteroid, that's what NEA stands for, that was 20 meters in size. So what does that mean? 66 feet? Anyone know? Name something that's 66 feet. Go ahead, off the top of your head. Yeah, there you go. It's also the length of a bowling alley, approximately. So that was kind of cool. So basically, an object that was the size of your alley that you'd roll your bowling ball down came over Russia. It exploded from the pressure of being in the atmosphere. It actually blew up at about 97,000 feet in the air, so above where you'd see airplanes or anything like that. But the impact was still obviously very visible. Nice, good job. And I highly encourage looking up these videos because you can actually see this from tons of different angles, and also you can hear the shockwave that happens. And the shockwave actually caused a ton of windows to explode from that shockwave. So there were injuries, but no reported deaths from this incident. It released 30 times the energy of the atomic bombs that were dropped over Japan. So it's pretty big impact for just a small little object. So if we go back even further, this used to be the canonical event. Unfortunately, Russia's been hit a couple times, but Russia's really big. And so on this, you can see where Chelyabinsk was, and now we have the Tunguska event. So the Tunguska event happened in 1908, and this was an object that came over Russia and exploded with such force that it leveled an entire forest area of about 800 square feet. This thing was probably about 65 meters in size, basically the size of the Notre Dame Cathedral. We'll go a little French theme in there. And it exploded at 26,000 feet. So if you were flying on an airplane, you could have even seen it explode below you. I would not have enjoyed that, 'cause that would have been pretty bad. But there was no major crater, so it didn't impact the Earth. They thought yes, thank you. So I picked this word. I knew I would forget. For a while, they thought it was a comet because it did explode, but for the most part, it's now probably considered to be an asteroid. And this is an actual picture from 1929, so that's pretty awesome, too, of the leveled forest. Less awesome. So there's other evidence of impacts. Guys, that was weak. Come on. That one I gave you. There you go. Cheers. There are other evidence of impacts that have happened on Earth. This one from 50,000 years ago, so we're going a little bit further back in time. But this thing is about 0.75 miles across, and if you were to go stand at the rim of it, you could actually fit the entire Washington Monument from the top to the bottom of the crater. It's in Arizona. Anybody been there before? I'm jealous. Well done, guys. I've actually never seen it. But they did actually find meteorites in this impact crater. And it was an iron object. So again, the composition matters, because if it wasn't iron, perhaps it might have exploded in the atmosphere, but something that's iron and not carbon or coal or like a stony rock that we sort of see on Earth, it can make it further through the atmosphere without exploding. So this thing landed and made a nice big impact. And the most famous of all events, of course, is the Chicxulub impact crater. That's my natural Mayan language that I can say. I don't know how to pronounce it, I'm sorry. But this is basically what we call the KT impactor, or apparently now it's called the KPG, the Cretaceous Paleogene impact event. There you go. And this is the event that did in fact wipe out the dinosaurs and 75% of all plant and animal life on the planet Earth. And this impact, basically they think the object was about 11 to 90 kilometers in size. So it's a pretty large object. Came in over the Earth, basically had the energy of somewhere between 20 and 900 billion times the atomic bombs. So it's a pretty energetic thing, pretty big impact. And the tidal wave would have actually made it all the way to Texas and Florida, and would have been higher and bigger had it landed in a different part of the ocean. The sea there is fairly shallow even back then, so that's the only reason it didn't do more water. But thanks. So I'm talking about stuff that's happened. What about what happens next? So what happens next? Do you think anything might hit us in the future? Yes. There's certainly that chance. So there's this object called Apophis. Who heard of Apophis? Okay. Apophis was this object that was discovered in 2004, and when they discovered it, it's fairly large, and they, from their calculations, realized there was a 2.7% chance that it was going to impact the Earth in April 2029. So that's soon, and this thing's pretty big. So they were worried, but they did a couple more observations, and they realized it was not going to impact the Earth. Yeah, we double cheers on that one. Not going to hit the Earth, and I said impact. But actually, what was crazy was that they did realize at that time that there was this chance that depending on how the asteroid passed the sun, it might cause the orbit to change enough that it would impact the Earth exactly 7 years later in the 2030s. So this was actually a big concern, and they kept talking about this keyhole event. If the asteroid passed within this very small keyhole region near the sun, it would actually hit the Earth in the 1930s. 2030s. It's a time hopper. I don't know. So it turns out it still won't, thankfully. But the object will come within 1/10 of a lunar distance. So basically, it's going to come closer than some of our actual satellites that we've put up, like geostationary satellites that we've put into space. So this is an image of all these blue dots are our satellites, and this is what Apophis is going to do in 2029. So stay tuned. Should be fun. These things happen, though, so there is always the possibility of an asteroid hitting the Earth. This plot right here, I'm just going to go briefly through, but down here is the size. So this is basically that Tunguska Event was kind of less than 100 kilometers. The KT impactor was about 10 kilometers in size, and this is how often it happens. So every year we should get some of these small stuff, but every 100 years, something like Tunguska. So hopefully that Chelyabinsk one kind of checked the box, we hope. But these things happen. So, did I scare you yet? Yeah? Officially scared? Don't worry. We scientists are here to the rescue. So, NASA does actually have a Planetary Defense Coordination Office where they find, warn, mitigate, and coordinate if there is an impactor. Come on, guys. There you go. On its way to Earth. And one of the things that they do, actually, is every year they coordinate a meeting that plans out what could happen if there was actually an asteroid that was going to hit the Earth. So they actually work with FEMA, they work with scientists, and they do a whole mock summary of what would happen if we detected an asteroid, and in X number of years, 10 years from now, that thing's going to hit. They figure out where, they pretend where it's going to hit, and they figure out what the response of Earth needs to be. So it's kind of cool. They also have a mandate, a congressional mandate in the US to find all objects, or 90% of all objects, that are 140 meters in size. Sort of an arbitrary number, but it's kind of one of those ones like, yeah, that thing would do a lot of damage if it hit, so like, let's find those ones. You can see we find a lot of them, and this is in part just due to better surveys, better telescopes, and more money to do it. So hey, write your senators and congresspeople. Thanks. And how do we do that? So I'm talking about that we need to find these asteroids. Basically, we do it the old-fashioned way in a lot of cases. We use optical telescopes, but we do these big surveys, so we're sort of scanning the entire sky all the time. An asteroid is going to move relative to the background stars, so you can detect it that way. We also need to characterize it, and one of the good ways of finding and characterizing asteroids is with infrared surveys, and that's because with infrared surveys, things that are dark but the same size, we're not going to see in reflected light because they're dark, they're cold, they're really, really, really dark, and they're not reflecting sunlight. But in the infrared, which is sort of that re-radiation of energy from the sun, they can be pretty bright. So we can actually use different wavelengths of light to find and characterize these asteroids. My favorite topic, of course, is planetary radar. So once we've found the asteroids, how do we know where they're going? So those optical surveys will tell us more or less. We'll get a good idea of where it's going and its trajectory. But planetary radar can really, really do this. So this is the Arecibo Observatory down in Puerto Rico. And this, yeah, cheers for Arecibo. I like it. Woohoo! They're dealing with like 3 weeks straight of earthquakes down there, so keep them in your thoughts too. The observatory, basically what they do is they send out a signal. It's not unlike the radar signal that a police officer might use to give you a speeding ticket, or the way that bats use sound to basically navigate their surroundings. It's sort of the exact same thing that this does. So from these observations, we can get things like the shape and the size of the asteroids, but critically for this talk, we can get super accurate position and velocity measurements using radar. So something that is tens of millions of miles away, we know where it is to the precision of a couple of feet. Yeah, it's crazy, right? And something going 10,000 miles per hour, we know how fast it's going with an accuracy of less than 1 mile per hour. That is, yeah, let me say that again, less than 1 mile per hour. We know exactly where these things are going, thanks to radar. They have to be close enough for us to ping them with radar, though, so that's the only trick. But once we know those things, we then know where the asteroid's going for decades, if not centuries into the future. So we can really say, this thing's definitely not going to hit us, or, oops, it's going to hit us. Luckily, right now, we don't have anything that has any real risk of hitting the Earth. We have not detected anything, at least, that has a good risk of hitting the Earth. So that's a good thing. So this is me at Arecibo. I was just hanging out, with my friends, Jodie Foster, Matthew McConaughey, and chilling on the platform there with Pierce Brosnan. For all of you here that are over 30, I would hope you recognize these movies. Everyone else, go find a VHS player or something and watch them. They're great. And so what do we do about it? So I've told you we're trying to find these things, and maybe we can figure out that they are or aren't going to hit. But what happens next? What if they are going to hit? So there's actually a mission being designed right now by NASA. It launches next year to see if we can understand what we can do about a possible impactor. Also, go NASA, right? So this mission is going to go to an asteroid that has its own little moon. So this is called Didymos, is the asteroid name, and this one they just called Didymoon, because why not? And so they're going to send a spacecraft, and it's going to orbit for a little while, check it all out, and then it's going to smash directly into this Didymoon. And what will happen is it'll still be close enough to the Earth that we can use planetary radar and we can use optical and infrared telescopes to study what happens to that moon after that impact. How quickly does it move away from the primary asteroid? How does it do something completely unexpected? Does it just absorb the impact and not move at all? Yeah. Less woo, because that would be bad if it impacts it and nothing happens. But these are the types of things that we want to be able to know. And this mission is basically a proof of concept of how at least one way we could potentially prevent an impact in Earth's future. We also need to know about the asteroids themselves. So we want to characterize the asteroids. We send missions to go to the asteroids so we can tell what they're made out of. So there's one mission ongoing right now that I've talked about at Astronomy on Tap before called Bennu is the asteroid, Osiris-Rex is the mission. It's currently there. It just picked a landing spot. It's going to touch down, grab some rocks, send them back to Earth so we can actually get a pristine sample of an asteroid and really know what these asteroids look like, what they do, how they evolve, and how they change. These are the radar images, and this is the model that was created, and this is the actual pictures now that we're up and close and personal with it. Well, I'm like really close to this camera. Hi, guys. So, how far? Did I do real bad? No, I did good. Okay, cool. So, I don't get stabbed by a glass as I was threatened with earlier. So to summarize, there's a lot of science to be determined when we're studying asteroids. We learn about how, by studying asteroids and what they're made out of, how they've changed, how they've moved throughout the solar system. We understand a lot about the solar system formation and how the solar system has changed with time. Also what it was like in the very beginning of the solar system. But we also can look at these hazards, these things we do call potentially hazardous asteroids that are very large and coming somewhat close to the Earth's orbit. I will reiterate right now, there are no asteroids currently on the path that we have detected that can do any damage to the Earth. So we don't have any asteroids that we're concerned about, but we certainly do see meteors come into the atmosphere fairly often, and we can detect them sometimes even before they impact. But the main thing is to look for these really big ones that could pose a bigger risk and maybe have us go the way of the dinosaurs. So we don't want to do that. The dinosaurs didn't have a space program, but we do. So support NASA, support our planetary defense, and hopefully we won't have this kind of an impact in the future. Thanks, everyone. Cheers.
Thank you, Tracy.
Thanks, Lizeth.
We had quite a few questions be texted in. The first of which, how big would an asteroid need to be considered a global killer?
Good question. And so again, it depends on what it's made out of, which is why we want to know that. But like the 140 meter size, that kind of arbitrary limit is sort of like the city killer size. How much bigger does it need to be? I mean, the dinosaur one was, right? So I guess it's like if you go back to that, oops, wrong direction. Oh, I canceled out of the whole slides. Christine. But yeah, I mean, something like 300 meters is going to do a lot more damage. But of course, once you get about that kilometer range, you're really going to mess up a lot of life.
Our next question, why is the Chicxulub impact energy range so broad? Wouldn't the crater size give us a good idea of the energy?
Awesome question. So yes, the crater size definitely gives us a good estimate on the energy, but it did happen truly 66 million years ago. So things have happened to that crater as well that have weathered the crater. It's under the ocean, it's under the sea right now. So things have changed that, and so I think there's also the question of kind of what angle it came in, and there's just a lot of uncertainties even in the size, and therefore how much energy was released. It's just hard when you're looking at something from that long ago. We still don't even have perfect estimates on the ones that we have all this footage and video cameras and pictures of, so it's hard to get a perfect estimate for that, but good question.
Was Arecibo affected by Hurricane Maria in 2017?
It was, yes. So let's see if I can. So this is a newer or older picture. I can't tell because basically this line feed right here, which isn't as needed for planetary radar, but the Arecibo Observatory does stuff with, they study the ionosphere, so our atmosphere, and they also study like just generally space, so like radio pulsars and things like that. This feed is useful for the ionosphere specifically, and this thing snapped in half and fell into the dish. The dish itself got warped during Hurricane Maria as well. So they're working, Congress and the National Science Foundation did award the observatory a pretty substantial amount of money to try to do the repairs from that hurricane, but it's still ongoing because it was that significant of a thing. But fortunately, compared to what could have happened, I think the telescope came out in pretty good shape, considering the devastation that had to the rest of the island. So,
two more.
Great.
What is the time scale of the Optical Telescope Survey image series?
I don't know. That's a good question. So asteroids will basically change their position. It can happen over the course of the night, or usually it's more like over a couple days. So you just kind of take those images every couple days, and you would see the asteroid really move compared to the background sky. So my guess would be probably like over the course of a few nights. That would be my guess. Someone can correct me. Yeah, that one. Yeah, so probably over a few nights.
Last one. The Tunguska Event was claimed to be a result of a hypothetical Nikola Tesla's death ray test. What are your thoughts?
I've never heard that. I like to say it was an impact. Most of the evidence points towards it being an impact, so that would be the more likely scenario than a Nikola Tesla crazy experiment in Siberia. Who knows?
All right, let's thank our speaker one more time.
Thank y'all.
All right, we're going to take a short break, and we'll come back with astronomy in the news. And make sure to visit our merch table during the break. One more note, if you guys could please not rush the bar, your server will be around to get your orders.
All right, welcome back, ladies and gentlemen. We are about to get started with the second half of our show. All right. Hello. Oh, come on, we can do better than that. Hello. All right, so my name is Sam Toback. I am one of the organizers here with Astronomy on Tap. So I am here to introduce our next presenters in the Astronomy Club at UTSA. So the Astronomy Club at UTSA exists to promote the knowledge and excitement that the science of astronomy brings to all. It is open to members from all majors at UTSA. They are very excited to be a part of the broader science community in San Antonio and South Texas, and we are super excited to partner with them for our Astronomy in the News. So let's give them a round of applause. All right, so presenting tonight for the Astronomy Club at UTSA is Caleb Gamar. He is currently a graduate student in the joint UTSA/Southwest Research Institute Space Physics PhD program and is a passionate communicator of all things space. So without further ado, I pass this along.
Thank you very much. Okay, so we have astronomy news here for you. Everything that's up in the heavens right now that is happening or going to be up in the heavens is in one topic I'll talk about. So, first off, how many of you, why did that do that? There we go, okay. So, yeah, great start, all right. How many of you have heard that the star Betelgeuse is getting dimmer? Yeah, a few of you, okay. So if you go outside in the sky tonight, you can see a star Betelgeuse. That'll be next slide. But it is getting dimmer, surprising enough. Usually it's around a magnitude 0.5 star, so that's actually pretty bright. Negative magnitude. Into the magnitude 2.0 range. And there's a lot of uncertainty as to why this is happening. Most likely, Betelgeuse does have very long-term variabilities in its brightness. You can see that here in the several recent year plots of its brightness variations. It's magnitude variations, I should say. Some have speculated that this star could go supernova. However, very unlikely to be the case. Cross your fingers, though. So, well, Betelgeuse is still there, and by the way, it is Betelgeuse. You can see it in the sky tonight. Just go out. We have 8 o'clock here. Actually, I'm going to say go out around 10 or 11 and look just straight south, and you will see the constellation Orion right in front of you in the sky. Orion has that nice belt of stars. If you look just up and to the left, you will find Betelgeuse, very distinct red-orange star. Do not miss some other sights in this part of the sky. We do have the Orion Nebula right there, a star-forming region about 1,500 light years away. Looks like a little gray fuzz in a pair of binoculars. Again, don't want to miss it. And a nice open star cluster just below the brightest star in the nighttime sky here called Sirius. Look right below it, right about there, and you will find something called Messier 41, which is an open star cluster, very young, very recently formed, about 200 million years ago. Yeah, that's recent, I know. 200, very recently formed stars about 2,300 light years away. It looks like a little glittery patch there in that constellation, so do not miss it. And we have a rather sad goodbye. The Spitzer Space Telescope has ended it's nearing the end of its life, should we say. Yep. Very successful mission launched back in August of 2003. It was only meant to last for about 5 years. As you can tell, it has well exceeded its lifetime, and it has given astronomers a sky survey called the Kilodegree Extremely Little Telescope. Yeah, I know, extremely little telescope. It's a wide-angle lens, basically, is what it is. Anyway, and this particular star system is about somewhere in the neighborhood of let's see, I'm trying to remember now here. It should be about 200 light years away, give or take a bit. Anyway, 7,800 degree Fahrenheit daytime temperatures. This is the hottest hottest atmosphere temperature exoplanet, I should say, discovery that has been made so far. And the contribution of Spitzer in this case has been the temperature measurements there. And a parting image from Spitzer, too. Really beautiful parting image. This has been kind of the farewell image in a lot of ways. It's been sent around. The Tarantula Nebula, and up there is the area where there was a supernova back in the 80s that happened called Supernova 1987A. This is in the large Magellanic Cloud, the closest irregular galaxy to us, a satellite galaxy of the Milky Way. So really beautiful image. But there are other telescopes out there that have just started their missions or in the earliest stages. TESS is one of them, Transiting Exoplanet Survey Satellite, and it has been tasked with shooting these very wide-angle images of the nighttime sky. Hold out your hands, stretch your fingers out this far. That's about 25 degrees, and the images that this telescope takes are about 25 degrees square. So it takes these mass images of those areas of the sky. And a couple of discoveries have been revealed recently with this telescope, namely a object, a exoplanet called TOI, TESS Object of Interest. Let's see, 700, if I remember correctly. Yes, TESS Object of Interest 700. Anyway, about 100 light years away. This is the first Earth type, Earth category, and again, be very careful with that. It's only about the right size, right distance from its home star, planet that has been discovered by TESS so far. So a major accomplishment there. And then a mission is launching soon, the Dawn of Solar Orbiter. Yes, this next week, if you tune in to NASA television, February 7th, 2020, 10:15 p.m., supposed to be, hopefully the weather turns out fine and everything, this mission will launch toward the sun. It is mostly a European-sponsored mission, but has some American contributions, even right here in San Antonio, Texas. Yes, there are a couple of our scientists at the Southwest Research Institute, Stefano Levi and Frederick Allegrini, that have worked with an instrument on this particular mission. So this will launch toward a solar orbit, and it will be in an orbit that brings it about to the distance of Mercury around the sun. So should be some interesting stuff in the coming years, and that is our Astro News. So thank you very much.
Hello, I'm back. Are you guys maybe wanting to hear somebody else talk about some space stuff? Possibly? Yeah? Okay, so our next speaker, Dr. Vincent Hugh. He is a planetary scientist working also at the Southwest Research Institute here in San Antonio. Thank you. He specializes in the study of giant planet atmospheres and their systems of moons. He earned his master's and his PhD in astrophysics from the University of Bordeaux in France. He is part of NASA's... Give it up for France. It's a great country. He is part of NASA's Juno mission, which is currently orbiting Jupiter. With Juno, he works mostly with the ultraviolet, or UV, instrument, which was also built at SWIRI in San Antonio. He is active in public outreach through programs in schools, as well as a co-host of Astronomy on Tap San Antonio. Yay! And finally, he is currently serving in NASA's Solar System Ambassador Program. And I'm going to let him tell you what his drinking word is, because I don't know.
Well, let's say if there's a Klingon invasion one day, they send the Solar System Ambassador to solve any problems. So one of the requirements is to learn Klingon, which is a little tricky to learn. But anyway, so tonight I'm not going to talk about Jupiter. I'm not going to talk about my favorite subject, but I'm going to talk about another subject, which is more related to the history of astronomy. And it's related to the transit of Venus. So, I'm going to share actually with you one of the things that fascinates me the most about the history of astronomy. It's how, from the relentless observation of the sky, we reach such an understanding of celestial mechanics to the fact that now we can send spacecraft to the outer solar system with a good precision. And a big chapter of that history was related to the Venus transit. This story involved some French people, some British people. And so my two words tonight would be French and British. So every time you hear the word French, you know what you have to do? Woo! And every time you hear the word British, you do? Well, according to that long rivalry between France and England, I agree that you should say boo or... No, you can cheer also, but not as much as for the French, let's say. So the story I'm going to tell is about how to scale the solar system, or the quest for the astronomical unit, which is the unit of distance between the sun and the Earth. And so before I start, I'd like to give some background information. And for instance, the Renaissance era was really a crucial time for me, not only for the arts, but also for astronomy. Because a couple of major books were published at that time, one of them being The Theory of Heliocentrism by Copernicus. Copernicus, yes. A little bit later, Kepler actually published his Rudolphine Tables, a major work where he predicted the position of the planets to the precision that was not attained at that time. For that, he used the numerous observations that were made by another astronomer, a Danish astronomer named Tycho Brahe. And so for the first time, we were able to predict the position of planets using both empirical calculations, some of his laws, and the observations. So with this table, he actually predicted that Venus would be transiting in front of the sun, which means that you have the sun and Venus transit in front of it. Easy to understand. So for an Earth-based perspective, only Mercury and Venus are transiting planets in the solar system. And the transit of Venus is actually very rare as an event, because the thing you have to understand is the orbit of Venus and the Earth they're not orbiting in the same plane. There's a shift of 3.4 degrees between the two orbital planes, which make this event very, very rare. And the transit sequence is actually interesting. You have a pair of transits separated by 8 years, and then you have to wait 105 years to have the second pair of transit, so two transits separated by 8 years. And then you have to wait 120 years to repeat the whole sequence again. So it's a pretty rare event. So Kepler, with his table, predicted that in 1631 there would be a transit. That was the first prediction of a transit in the history of astronomy. Unfortunately, that transit was not visible from Europe, where most of the astronomy were going on at that time. And he also predicted that in 1639 there would be not a transit but a near miss, which means that Venus would be going very close to the sun but not transiting. So now you have to understand that those tables were made using one of the last set of naked eye observation made by Tycho Brahe, because after that everybody used telescopes. And though they were precise but not extremely precise. And what some British So what two British astronomers did at that time, they used their telescope and they observed Venus and refined the prediction of the position of Venus on the sky. And they actually predicted that Venus would be transiting in 1639. Of course, at that time, they didn't know the pattern of occultation, of transit. And those two British astronomers, thank you. I'm going to cheer for that. Those two British astronomers were Horrocks and Crabtree, the two only observers that observed, and the two first observers of the Venus transit in 1639. Well, unfortunately, Horrocks was 22 at that time, and he died like a few months after the transit. So the technique to use to observe the transit is to use a telescope. You project the image of the sun on the screen with like a grid to be able to measure properly, and then time and measure where Venus is transiting in front of the sun. Okay, so I cannot mention this piece of history without mentioning Newton, who published his Principia, providing the law of universal gravitation in 1687. And so at that time, I have to mention another British astronomer who played... Boo! Well, most of these guys are superstars, so if you boo them... So the next guy I'm going to mention is Edmund Halley, who played an important role in the history of the transit of Venus, because he actually proposed that we could use the transit of Venus as a way to measure the solar system, as a way to scale the solar system. Because at that time, we knew the law of universal gravitation, we knew the law of Kepler's, and so we knew the relative distance between the planets. We knew that since the Earth is rotating in 1 year, Venus a little less than that, Venus, according to the law of Kepler, is supposed to be 72% the distance between the Sun and the Earth. So they knew the relative distance of the different planets. Like Jupiter, they knew that the rotation was much longer than the Earth, and they knew that it was like 5 times more distance from the Sun than Earth is. But they didn't have an exact number on what was the distance between the Sun and the Earth. And what Edmund Halley did was proposing to use the transit of Venus as a way to calculate that number. So what he proposed to do, he proposed to do that for the next forthcoming transit. Unfortunately, he died. That was his lifetime, so he never saw any transit out of his lifetime, unfortunately. But he motivated the scientific community to observe this event in 1761 and 69. So in his method, he proposed that 2 observers should travel in the world and as far distant as possible, one from the other, and time the transit of Venus exactly with a high precision. Especially they're interested in like the first contact, the second contact, and the third contact. So like when Venus is really start to be really inside the Sun, and then when it touches the other side. And this is when I should talk about a French guy this time. Oh, there's a British corner here. His name is Jean-Nicolas Delisle, and he was an astronomer in the Paris Academy. And he actually refined the method proposed by Halley he proposed a different method, which is still based on timing the direction of the transit, but a slightly different method. And he also published these beautiful maps. So this map dates from 1760. That's when he published it. And as you can see, it's interesting because at this time there was still some part of the world that were unexplored, like the entire coast of Australia were not explored, Antarctica was not explored. And on this map, he has shown where the transit would be visible. Because the transit takes about 6 hours, so it's a long event. To record the entire transit, the rotation of the Earth is such that, well, in some parts you might just see the beginning of the transit and then the sunset, and other parts, when the sun rises, you see the transit has already begun. So the transit was mostly visible in that region of, mostly around Asia, India, and in the Indian Ocean. And so that's what they decided to do. They decided to send as many astronomers as possible in 1761. And that was actually the first large-scale experiment, the first big science where many astronomers would coordinate the same astronomical observation in very different places. So for this 61 transit, 120 observers went in the world in 72 stations. This is the transit map visibility. This is where you can see the entire transit. In those regions, you can only see part of it. And most of the observers, yes, and I should mention that there was a big war at that time that we can call the World War before the First World War, because it was a big war between the United Kingdom, the Kingdom of England, allied with Prussia, Portugal, and its allies against France, Austria, Russia, Spain, and they were like fighting all over the map for like the naval control and colony, and so that was really a big deal at that time, especially for astronomers. They had to go through war zones to actually time the astronomical event. So that was a crazy time. Especially astronomers at that time, they had a key role because they could determine longitude and latitude of places. They could make maps. They were often taken as spy. And so they were very literate, so they knew, So they had a key role at that time. But nevertheless, they were able to spread across the world. This was the position of the main astronomers for this first transit. I'm going to mention the first few things that were discovered during that transit. First of all, the black drop effect, which actually was a big bummer for most observers because it's an effect caused by the limited resolution of most telescopes, combined by the fact that the brightness of the sun decreases, the limb darkening that you see, and you have this channel of darkness that forms, and so which makes estimating the time of the contact very difficult. And since the method to determine the Sun-Earth distance was mostly based on like extreme precision of those contacts, they discovered this effect and they were like, oh yeah, we're going to do the best we can, but we cannot go over this effect. So this was some of the drawings that were made at that time that illustrate this effect. Another thing that was discovered was that Venus has an atmosphere, actually. They saw a sort of a halo when Venus was going outside and inside, which was the evidence that Venus has actually is refracting light and it actually has an atmosphere. So a lot of things were discovered, and this discovery was made by a Russian astronomer. So if there is any Russian in the room, woohoo! They're gone. So that was the 61 transit. They knew they had another shot 8 years later. So that's what they decided to do. This was the visibility map for the 1769 transit. Well, as you see in this case, the best spot was probably Hawaii. So like right in the middle of the Pacific Ocean, which was not the easiest way to get there. For this event, like 151 astronomers went over 77 observing stations. This was the location of most of them. I can mention like the Cook, Captain Cook, during his first navigation, his first world exploration. He was planning to stop in Tahiti to observe the transit, and he made some fantastic observation because the weather was amazing at that time. Yeah, that's another thing. Some observer would travel across the world to arrive at a place where the weather was just bad. So, so that was there's a lot of stories about it. And so actually with those two transits, they actually reached a value that is 1% close to the current value that we know. So that was really an amazing achievement for the entire community. Even though they were expecting to have a better accuracy, it was still very good for that time. So what I'm showing here, this plot shows because the transit of Venus is one of the techniques to determine the Sun-Earth distance. There was a lot more other techniques. And on this plot, you see, as a function of year, the value those techniques give for the Earth-Sun distance. And you can see that the transit of Venus arrived right at that one point where most techniques converge to the value that we know now. So that was really a shift in the paradigm of how big the solar system is at that time. So that was a big deal to realize how big it was, things were. And then I can mention that now we have much better way to determine the Sun-Earth distance. Let's say Tracy talked about radar. Using a pulse radar measurement and getting the echo back from a planet like Venus is a good way to determine like distance with a very good precision now. All right, so before I finish, I haven't said the word French too much, I think. And I'm going to say it a couple of times now. I'm going to illustrate some of to pay a tribute to those astronomers. Some of them were French, that sailed across the world, fought wars, fought dictators in colonies somewhere to make those crucial observations. And they were obsessed about it. So first I'm going to talk about Jean Chap, who's a priest actually, Jesuit. And this guy is actually very interesting because he travels to Siberia. So he has to go through Prussia, which was against France at that time, even though Russia was an ally of France during the 7 Years' War. He goes through all the way Siberia to center of Siberia to observe, to build an observatory in Tobolsk in Siberia. So he goes, of course, with all his instrumentation, which you can imagine is not convenient, especially in war zones. He built the observatory. He observed the transit. This is one of his drawings from the book he published when he came back, A Journey into Siberia, which at that time was a big deal because he talked a lot about the population of Siberia, and it threw a big diplomatical issue because the Tsar of Russia, Catherine the Great, at that time didn't like the fact that the French guy was talking bad about their population and how the lifestyle was in the countryside. So that was interesting. But then he didn't stop here. He was enrolled to a second mission 8 years later. He's sent to Baja California in San Jose del Cabo to observe the transit. So he goes to Mexico, he crosses Mexico and go to Baja California. But the thing is, when he gets there, there's an outbreak of yellow fever when he has to set a few months before the transit, and so he cannot change the location. So he observed the transit, and he has to stay later to observe another astronomical event to be able to determine with precision the latitude and longitude of the place, which is crucial to validate the method, to have exactly where this observation was taken. And he dies 2 months after the transit, unfortunately. So like out of his 30 members of his crew, of this expedition, only 2 survived. That was a big deal. But this is the only astronomer who actually observed both 18th century transit successfully, and he brought like measurements. So that was incredible. Another guy named Guillaume Joseph Hyacinthe Jean-Baptiste Le Gentil de la Galicière. No, it's not a joke. It's not a joke. I mean, this guy hated name tags, definitely. French guy. And so this guy has a crazy adventure in the Indian Ocean. He sails to observe a transit in India, in Pondicherry, which was a French colony in 1760. But it became, shortly before arriving there, a British colony, which was at war with France. Boo! So he had to head back, and unfortunately he has to observe the transit on the ship with the best observing condition ever. You know, like the rocking deck of the ship. But nevertheless, he decided to stay in the region to observe the next transit later. So he waited 8 years in the Indian Ocean. He makes contribution to geography, natural history. He makes map of Madagascar, for instance. Astronomy, navigation, and he decided to go to Manila in the Philippines to observe the next transit. But there, Manila is ruled under Spanish kingdom, and the governor from Spain thinks he's a spy and makes everything impossible for him. So he decided to go back and actually go back to Pondicherry to observe the transits. And there he arrives. Pondicherry was handed back to France after the 7 Years' War. He arrived in Pondicherry, ready to observe. In the morning, bad weather, clouds. And the worst thing about it is that later, after the transit was gone during the day, the weather was perfect. And the weather was good also in Manila that day. So, of course, and then he came back 12 years after having left France. He's presumed dead. All his family has split his heritage. So that's a very unfortunate destiny for him. But he's actually able to go back to the academy, reestablish all his heritage, all his belongings. He gets remarried because his wife has left him, of course, too. So yeah, fun time for him. But he had a happy end of his life right before the revolution, the French Revolution. All right, so the latest, I haven't talked about the 19th century transit because I felt like this was already a lot, and this was like the pioneer measurements of this transit, so I really want to spend some time on that. But the last transit was actually in 2012, and I'm going to show a video of that transit that was made by NASA. And I'm going to see you at the next transit of Venus, which would be in December 21. So you better start drinking vitamin to stay young, because So thank you for your attention, and I'm going to let this video running for the end. Thank you. That was a video made by a couple of different observatories showing how Venus goes in and out of the sun. There are still some science that were done with this transit, actually. All right, do we have any questions?
We do. Is this on?
Yeah, it's on.
Okay. Is this at its end?
It's okay, we can talk.
Okay. Well, we watched this pretty video. Okay. So our first question, who is your favorite old world astronomer involved in scaling the solar system, and why?
I think it would be Kepler.
Okay.
Yeah, definitely Kepler.
Why?
Because he had to befriend Tycho Brahe, which was a crazy astronomer
Okay.
who just liked to observe the sky and not share any of his data and just be obsessed about the precision. And he used his data to understand how things were moving, and yeah. So, and then he makes his law and was about to predict. And it was like a hint to the work of Newton's, who later came and unified all his law into this beautiful universal gravitation law.
A lot of good reasons. Yeah. Okay. Next one. Is the next transit of Venus visible from San Antonio?
Well, are you planning to be there?
Grandkids
You want
somewhere.
to freeze yourself to be able to watch the event? Or? No, I don't know. I haven't checked, actually. That's a good question. Yeah.
Okay. Okay.
But the thing is, it's interesting because the parallel transit, they occur in the summertime, in June, the two transits. And then the two next transits will occur in December, so in the winter time. So the next would be actually winter time for the northern hemisphere, which might cause the fact that, I mean, it might be possible to observe it, but it's not as likely as if we were in the southern hemisphere.
Okay. So we should all fly to Australia, but that
Yeah, probably.
in 100 years.
Yeah.
Okay. Okay, question 3. Why was Venus the ideal planet to use to measure the astronomical unit? Why not Mercury?
Well, because Mercury has the weird orbit compared to Venus. It's not as circular as Venus. And it's moved quite fast, which made Venus a better case to time. Yeah, that was the main reason. And actually they tried, I didn't talk about the transit of Mercury, but the transit of Mercury, which are more frequent, were actually a rehearsal for the transit of Venus at that time. And some French astronomer, Gassendi, actually tried to measure the astronomical unit with the Venus, the transit of Mercury before the transit of Venus. Okay. So that was, yeah, that's a good question.
Okay, 4. Are other exoplanets like Earth, as in planets that are also in the habitable zone of their stars, about the same distance from their host stars, or is there a lot of variation from star system to star system?
Yeah, we see a whole range of different planetary systems with very compact system where within the orbit of Mercury, on the different system you see 5, 6 planets, so very hot. But yeah, there's planets that are in the so-called habitable zone where if you take the Earth and bring it there, it would have liquid water. So yes, I stopped to lose count of them because there is actually so many we discover. So there is potential habitable planets, definitely.
So somewhere there's an alien, Kepler and Newton, looking at their version of Venus out there.
Probably.
Okay. Maybe we'll meet them one day. Okay. Last question. Can you say that Guillaume, that guy's name again?
Okay, let's go back. So I think it's simple to just call it Le Gentil, which means the nice guy. But otherwise, his full name is Guillaume Joseph Hyacinthe Jean-Baptiste Le Gentil de la Galicière.
Okay. Let's give it up for that
So
pronunciation and for our speaker, Vincent, again.
Thank you, guys. Thank you. Thank you to the host.
Okay, I think next we're going to tell you about upcoming events.
Oh boy. Okay.
Oh.
So I don't know why this one's saved like that, but good for you. I have a screenshot. All right. So how many of you enjoy informal science learning like this? Awesome. Me too. So Astronomy on Tap focuses a lot on astronomy, but I don't know if you know this. There's another group in San Antonio called Taste of Science. They have very similar style events where you get to drink, you get to eat, and you get to learn about cool stuff in these informal settings. So tomorrow night on 1-30-20 at 7 p.m. at the Oak Hills Tavern, Taste of Science is hosting Science Trivia. That is going to be at Oak Hills Tavern. Astronomy on Tap will be sharing that event if you would like to go learn some cool science trivia, maybe win some cool prizes that we won't have here tonight. That would be a really great opportunity. Oh, I set this down. Oh, thank you. Awesome. So on Friday night, apparently this is just the week for informal science, right? So Friday night's Celestial Lights lecture series, that is up at UTSA. That is going to be this Friday, January 31st at 6:30 p.m. Another really great opportunity for you to learn more about science and specifically astronomy. All right. Coming up on February 5th, so next week, right? The Trinity University Distinguished Scientist Lecture Series is going to have a really, really fantastic special speaker. So definitely check that event out. We will also be sharing that information on our Facebook. And last but not least, on February 20th, so quite a ways away, is at SAMSAT, so the San Antonio Museum of Science and Technology. a fairly new institution here in San Antonio, that is a really great opportunity for you to continue learning about space science. And of course, last but certainly not least is the next Astronomy on Tap. So come join us again on February 26th, right here at Blue Star if you want to continue learning about space, drinking beer, and having a lot of fun. Thank you all so much for coming. Remember to check out the merch table. And thank you to our guests. Don't forget to tip your wonderful, wonderful wait staff. And thank you, Blue Star, for hosting us.